Okay, let's just dive right in. The entire AI video world has been, completely obsessed with one single technology. But Apple, they just dropped a massive curveball. It's a brand new video model called STARFlow V. And honestly, it's not just some alternative. It feels like a bet on a completely different future for AI. So, what exactly did Apple build here? And are we looking at the beginning of a post-diffusion era?
So, in this breakdown, we're going to get into all of it. First, we'll cover the current king of the hill diffusion models. Then we'll unpack Apple's pretty bold move to get away from that. We'll get into the weeds of how this new tech actually works, and then we'll look at the controversy around its so-called open release. And finally, we're going to ask if its biggest weakness might just be its greatest strength. To really get why STARFlow is such a big deal, you first have to understand the world it's walking into. And right now, that world is, well, it's incredibly noisy, both literally and figuratively. I mean, just think about it for a second. OpenAI's Sora, Runway, Stable Video Diffusion, they're all basically singing from the same hymn sheet. They're all built on the exact same foundational idea. And yeah, this has led to some incredible results, but it's also created what's basically a technological monoculture, and that can be dangerous. And that one big idea, it's diffusion. The logic behind it is actually pretty elegant. You teach a model to be an expert at denoising. You take a perfectly clean video, you just obliterate it with a random noise, and then you train the model to clean it up, step by step by step. Once he gets really good at that, you can just hand it a screen full of pure static and say, go on, find a video in there. And look, let's be clear, this method works astonishingly well. I mean, the quality we're getting from models like Runway Gen 4.5 is just mind-blowing. But all that power comes at a pretty steep price. The process is incredibly slow, it's iterative, it requires hundreds of little steps to clean up all that noise. And that means it needs just colossal amounts of computing power, which basically confines these amazing tools to massive, expensive data centers up in the cloud. And this is where Apple, a company that is famous for on-device performance, decided to place a very, very different bet. Instead of jumping into the diffusion arms race, they've just decided to sidestep it completely. This quote really just nails the feeling, right? Nobody was expecting a major release like this, built on a completely different architecture. It's a huge strategic pivot away from the mainstream, and it signals that Apple believes the fundamental problems with diffusion are a dead end for what they want to achieve. So what is this different approach? Well, it's a technology called Normalizing Flows, and the core idea is just fundamentally different. Instead of that slow, messy, step-by-step cleanup of static, a normalizing flow learns a direct, elegant, mathematical transformation. It takes that same random noise, and in what is basically a single, continuous step, it morphs it directly into a coherent video. No iteration, just a pure, direct conversion. All right, let's get into the mechanics of this, because the difference here is fundamental. It's not just a faster way to do the same thing. It's a completely different way of thinking about generation. This slide really gets to the heart of it. On the left, you've got diffusion. It's powerful, sure, but it's a brute force iterative process. It's basically guessing its way back out of the noise. On the right, you have normalizing flows. Single pass, fast, elegant. But the real game changer, especially if you're a researcher, is that middle point, exact likelihood. Let's break down why that is so important. So here's the crucial difference. A diffusion model never really knows the probability distribution of the data it's working with. It just learns a process to kind of approximate it. A normalizing flow, on the other hand, learns a direct, invertible mathematical function. This means it can calculate the exact probability or likelihood of any given video. Now, why does that matter? It means you can do things like anomaly detection or data compression way more effectively. It gives the model a rigorous mathematical grasp of the data that diffusion models just don't have. It's not just an engineering trick, it's a huge leap in theoretical elegance. So how did Apple actually pull this off? Well, the secret sauce is in their architecture, which they call Transformer Autoregressive Flow, or STARFlow. Now, a standard autoregressive model is slow. It generates frame 1, then it uses that to generate frame 2, and so on. But Apple uses this really clever mathematical trick called video-aware Jacobi Iteration. This lets the model generate multiple frames in parallel without breaking the causal flow of the video. This is then combined with a deep, shallow design where one massive transformer does all the heavy lifting. And crucially, all of this happens in a compressed latent space, basically a low-dimensional summary of the video from an autoencoder, not on raw pixels. This is the innovation that makes normalizing flows for video actually viable at this scale for the very first time.
So Apple has this groundbreaking research, and in a pretty surprising move, they released it with open weights. But as the developer community very quickly discovered, open at Apple means something very different than it does pretty much everywhere else. This comment from Hacker News just perfectly sums up the community's reaction. There was this initial excitement, which was immediately followed by disappointment as people started digging into the fine print of the license. Apple is basically letting you look, but not much else. It's look but don't touch.
Yeah, let's be really explicit about these restrictions. You want to use this in a commercial product? You need to get written permission from Apple. Want to fine-tune the model and then share your improved version? Well, you need Apple's consent for that too. And to top it all off, the actual model weights aren't even out yet. The repository just says, coming soon.
And, this didn't just happen in a vacuum. This release seems to be a direct result of some internal tension at Apple. Earlier this year, reports claimed that software chief Craig Federighi vetoed plans to fully open source other models. That led to a bit of a talent exodus, including the head of their foundation models team. So this weights available release, it feels like a compromise, a way to gain credibility and a spotlight at the big NeurIPS conference without actually giving up any real control. But the licensing isn't the only catch here. There's also the quality. The output from STARFlow V is, to put it mildly, not really on par with the competition. But as we're about to see, there might be a very, very good reason for that. I absolutely love this quote from the community feedback. For anyone who remembers early AI art, that Will Smith eating noodles meme is just iconic for all the wrong, distorted, uncanny reasons. The first STARFlow V examples have that exact same vibe. They're blurry, they're full of artifacts, and they're just a little off. And this table really puts it in stark contrast. Just look at the metrics. Resolution, 1080p versus a measly 480p. License, a commercial API versus research only. I mean, on the surface, it looks like a total failure. But then you get to that last row, target hardware, data center versus on-device. This is the whole key. Apple isn't building a competitor to Sora. They're building the antithesis of Sora. They're building for the iPhone in your pocket. So here's the crucial takeaway. Judging STARFlow V on its quality today is completely missing the point. This is Apple's MobileNet moment for video. For those of you who remember, MobileNet wasn't the highest quality computer vision model, not by a long shot, but it was the first one that was efficient enough to actually run on a phone. And that's what STARFlow is. It's designed from the ground up to be the first powerful generative video model that can run locally on device. And in that context, the low resolution isn't a failure, it's a design choice. It's a feature of its efficiency. And that leaves us with the big question. Is Apple's STARFlow V just a low-quality model with a restrictive license that can't even compete with the big dogs? Or are we looking at the blueprint for a future where generative video isn't just something we access through the cloud, but a creative tool that lives right on our devices? Apple is betting everything on that second one.